Chapter 9, Section 4 in the 8th grade note-taking guide is entitled Measures of Central Tendency. So we're looking once again here at the ideas of mean, median, mode, and range. But we're not really spending so much time looking at them just in the perspective of mean, median, mode, and range. What we're going to be doing is finding the mean, median, mode, and range, and then using that answer to describe which of those values best describes a data set. That's really what we're going to spend time on here today. So let's start off with the definitions here. The mean is the sum of a set of data divided by the number of values in the data set, sometimes referred to as the average. The median is the middle value, or the mean of the two middle values in an ordered set of data. The mode is the value that occurs most frequently in a set of data. The range is the difference between the least and greatest values in a data set. An outlier is a value that is either far less than or far greater than the rest of the values in a data set. And a weighted average, which is really a new concept because we didn't talk about this last year in the 7th grade book, so I'm guessing you didn't see it before that. A weighted average is a mean that is more strongly influenced by some data values than others. All right, and with all that in mind, let's go ahead and take a look at the first example here. In the first example, they're asking me to identify the outlier in the data set, and then we're supposed to determine how the outlier affects the mean, the median, the mode, and the range of that data set. So, as we take a look at this question here, we're going to go ahead and start down this right column, because this right column here is the one that does not include the outlier, so we don't need to learn anything new here. We can go ahead and use the data we already have in our brains to solve. So start off here, they're taking this list of numbers and finding the mean. So of course, if we're finding the mean, we add up all the numbers. So we add the 21, the 21, the 28, the 29, the 51, the 28, and the 32, which is what you can see they've done in the top here. And then you divide by how many numbers are on the list. Well, as you can see, there's 7 numbers in that list, so they divide by 7. So this is the equivalent of 210 divided by 7, which is 30. So those numbers average out to make 30. The median is the middle number when they're in order from least to greatest. And as you can see looking at this list here, as I count in from the outsides, I have a perfect middle number, which makes this really easy, 28. 28 is the middle number when they're in order from least to greatest, so the median is 28. As far as the mode goes, the mode is the number that shows up on the list most often, and we have 2 numbers that show up on the list twice, and that is the greatest number of times any number appears. So the modes here are going to be 21, 2 of those, and 28, 2 of those. And then of course the range is what we get when we subtract, find the difference of the big and the small numbers. So I'm doing 51 minus 21 here, which changes into 30. So these numbers have a range of 30. All right, let's go ahead and go back and look at the left column here now. In the left column now, they want me to first throw out the outlier. Well, as you can see, the first thing we did here at the top is we identified the outlier. An outlier, in case you've forgotten from last year, we touched upon this last year, it might have been the first time you saw it. An outlier is just a number that doesn't fit in with the rest of the data. For instance, if I was talking about your math test scores, and you had a 90 and an 85 and a 75 and a 65 and a 90 and an 80 and a 70 and a 95, and then you scored a 5 on the last one, 5 would be an outlier. It's an outlier because you got a bunch of passing scores, and then all of a sudden you've got this failing score that's way far away in terms of percentage from the rest of your scores. That's what makes it an outlier. It just doesn't fit in with the rest of the data. So we're going to throw that number out. Throw it off the list here, and then we're going to recalculate all these things, and you're supposed to figure out what's going to happen to the mean, the median, the mode, and range when we throw out that number. So let's start with the mean. We're throwing the 51 off the list, which is going to knock the total down considerably, and then we're going to divide by 6 instead, because there's only 6 numbers left on the list when I get rid of 51. And as you can see, that went down, made the mean go down to 26.5. No surprises there. If I throw out a big number, of course, the mean is going to go down. That's like saying if I give you a bunch of your test scores and I said, I'm going to take the 100 away from you. Well, if I take the 100 away from you, your grade's going to go down because I'm taking away one of your better scores. Right, the median is the middle number when they're in order from least to greatest. So the same list we just saw, but of course 51 is gone. Well, as I count in here from the outsides to find my middle numbers, I see that I have two middle numbers here, two 28s. So when there's two middle numbers, you average them. Well, if I average 28 and 28, the average is still 28. So here, the median didn't change. Kind of coincidence, but it didn't change. Mode, number that shows up most often. Well, even getting rid of 51, 21 is still there twice, 28 is still there twice, and that's the greatest number of times any number appears on the list. So that does not change either. The modes are still 21 and 28. And then the range is the difference of the big and the small, so 32 minus 21. And when I do that, that's 11. No matter what number I get rid of, a small number or a big number, if I've got this large list of numbers and then I take away something on one of the ends, the list of numbers is going to get smaller. So the range is always going to get smaller when I throw something out on the outside. So the range here went down simply because of the fact that the list of numbers that I'm looking at is smaller. All right, so what happened here? Well, as we can see, taking a look at the numbers we've tabulated then, and then what they want us to do is identify here. The mean went down by 3.5. Again, no surprise because we threw out one of the big numbers. When you throw out a big number, your average is going to go down. The range changed quite a bit. The range dropped by 19 here, but the median and the mode didn't change at all. They are still exactly the same. They are exactly what we started off with. All right, in number 2 here, they're asking you to determine and find the most appropriate measure of central tendency for each situation, and then they're asking us to justify our answer. It says competitors receive the following scores for their performance in a competition: 9.3, 8.3, 8.5, 9.1, 8.2, 8.9, 0.8, 8.7, 8.8, 8.1, 9.2, 9.0, and 8.6. What best describes these scores? Okay, so what they're asking you here is to tabulate these different things we've just tabulated and figure out which one best represents that whole list of numbers. Now, there's not a golden answer here. It's not like, oh, it's the mean this time, so it's always the mean. No, it's actually based on you doing the calculations and then looking at the list. It's going to be different based on whatever number pops up as part of the calculation and what actually then is on that list. I will tell you one thing right away. Range is almost never going to be the answer unless it's a total coincidence. Don't bother looking at the range. Spend time on mean, median, and mode. One of those three is going to be the number that best resembles your list here. So, as we take a look at just those three here, let's start with the mode here. All right, and the reason I'm starting with mode is because the first line here is talking about the mode. We don't see any number that repeats here, which means there is no mode, which makes this even easier because there is no number here for that, so mode will not be the answer. So that only leaves us the mean or the median to take a look at. Now, as you can see, they put the numbers in order because they wanted us to find the median, of course. Well, as we look through this list here, there's 13 numbers, and so we're going to count in to find the middle number, number 7, the 7th number on the list, is my median, my perfect middle number. And that worked out to be 8.7, as you can see. All right, and they're saying here that the median best describes these pieces of data. Now, I'm not going to find the mean. We can, but I'm going to tell you why I'm not, and it'll make perfect sense. I have 0.8 on this list, which is a really small number. If I take the average of all these numbers, all right, the whole list, including 0.8, what's going to happen? Well, you already know. Let's say these were all the test scores you had. And then all of a sudden we added this guy on, which is really, really low. All right, what's going to happen to your average? It's going to make the average go way down real quick. It's going to drop like a rock. All right? We know then that this 0.8 is going to take this whole list of numbers and drag that list down. All right? 8.7, on the other hand, that we found for the median is right in here. It represents a lot of these numbers here happen to be right around that 8.7. Whatever this number is here, when I find the mean, the average, is going to be low because of this 0.8. It's going to drag it down towards here. So whatever it is probably going to be down here on the list. Well, a number down here doesn't best represent this whole list of numbers. A number right in this area here best represents this whole list of numbers. So that's why we're saying that the median best describes the scores. Again, you're just looking for which number best represents your data. All right, if we had a bunch of these 0.8s, a number down here would make perfect sense. But the average here, where it's going to get dragged way down when most of these numbers are up here in the 8s and 9s, doesn't ever make any sense, not in our situation here anyway. So here, the median best describes this whole list of numbers. All right, let's go ahead and take a look at example 3 here. In number 3, it's asking me to find the weighted average. Now, we have not done weighted average. We did not do weighted average in 7th grade, so this is an entirely new concept for us. All right, what it says here is that on a recipe website, members are rating a lasagna recipe. The website awards 3 points for an excellent rating, 2 points for a good rating, and 1 point for a fair rating, and none for a poor rating. What is the weighted average of the ratings? So, what you can see here is you've got 32 people who rated this recipe excellent. Well, for each of those, they're going to give you 3 points. So in essence, they're saying take that 32 and multiply it by 3. It's like getting a 3-point shot on the basketball court. I take a shot, it's from the 3-point range. If I hit 6 of them, 6 3-point shots is, of course, 18 points because I'm taking 6 and multiplying it by 3. Same idea here. 32 excellent ratings, they're worth 3 points, so I'm multiplying it by 3. Good ratings are worth 2 points. So I have 59 of those, so I'm going to end up multiplying that by 2. Again, it's like a 2-point shot. If I hit 7 2-point shots, how many points did I score? Well, I do 7 times 2 and I get 14. Same idea. All right, 1 point for a fair rating. So I have 129 times 1. Again, I can go right to that basketball idea. If I have 29 here, 29 free throws,
Each one is worth a point. 29 times 1 is 29. And then no points for a fair rating. So I'm going to take this poor number here and multiply by 0.
Again, this is like the 15 shots I took and just totally missed. I don't get anything for that. So I'm multiplying that by 0. And that's where you're going to start here. That's what the top of the solution is. It's just like finding an average, because remember, they defined it for us as being an average. So what you're going to do now is go ahead and take and divide by the total. So you got to add all these up now, just like we would always do when we find the average, and divide. So I add all those up. That's 135. This set of multiplication with the adding gave me 243.